Hi, welcome to Hubble's Universe Unfiltered. I'm Dr. Frank Summers of the Space Telescope Science Institute. In March of 2009, we held a contest that we called Hubble's Next Discovery, You Decide. And in that contest, we gave you a choice of 6 different astronomical objects that Hubble had never observed before. And we let you decide what would be Hubble's next observation. Well, we received over 140,000 votes, and the winner, garnering almost half of the votes cast, was the interacting galaxies ARP-274. Well, after this astronomical object won the contest, I decided to take a look and see what more information I could find out about it. Because, the image that we used for you to choose was from the Digital Sky Survey, and it's really low resolution and black and white. So I searched the internet for more images, and unfortunately, I couldn't find really great images. The best I could find was actually the original image from the ARP catalog. You see, this is called ARP-274 because in the 1960s, Holden ARP put together a catalog called an Atlas of Peculiar Galaxies. He surveyed all his astronomer friends and said, which are the galaxies that look kind of unusual, ones that just don't look like your standard spirals, ellipticals, galaxies. And he put them into a large catalog that we now call the ARP catalog. And so this is the image of the 274th entry in the ARP catalog, and we call it ARP-274. Now, this is an image from the 1960s, and Hubble took its observation in April 2009, so of course it should do an awful lot better. Well, yes, this is Hubble's image of ARP-274. Quite an improvement, but then again, it is 40 or 50 years later in terms of technology. So this is Hubble's image of ARP-274. This is the image that you asked Hubble to take, and here it is for you. Unfortunately, it seems we lied a little bit, because we build this as interacting galaxies. But when I look at this, I don't see much evidence of interaction. There's no evidence of strong interaction. If I were going to show you strong interaction, I might show you this image of ARP-194, another entry in ARP's catalog. This is an image that Hubble took very recently and was released for its 19th anniversary. And here you see a center of a galaxy here and the center of a galaxy here, and the arms are being pulled across this way, and there's stuff splaying out over here and stuff splaying out over here and stuff going off down here. Plus you also see some very bright blue star forming regions, which is a good strong evidence of interaction, because when galaxies smash together, the gas clouds collapse and you get bursts of star formation. So these are interacting galaxies. But ARP-274, not so much. There's really not much interaction going on here. And so we really don't see what ARP called these peculiar, it's in his catalog of peculiar galaxies, but really don't see much peculiarity here. Although, I gotta say, there is one sort of peculiarity. I mean, look over here in this region. See, what I see here is that this galaxy in the center is in front of this galaxy here on the right. So, although they haven't interacted yet, they may be in the process of approaching each other so that they will interact. But up in here, you sort of see an overlap region, and there's something sort of peculiar in there. Let me zoom in on that. All right? And what seems peculiar to me is this sort of long linear feature here, and then have a linear feature here, and it looks a little bit like that the spiral arm takes a sudden left turn, and spiral arms are generally smooth and, as the name suggests, curvy shaped things, and they really don't take left turns, sharp 90-degree turns. Well, as I said, this is the overlap region between this galaxy, which looks to be in the foreground, and this galaxy over here that seems to be in the background, and so I really can't tell exactly what's going on here. It just is kind of funky. So, although these galaxies were in ARP's Atlas of Peculiar Galaxies, they don't really seem all that peculiar. However, the story doesn't end there. Because in seeing that this galaxy looked like it was in front of this galaxy, I did a little digging on these galaxies and tried to figure out what data there was about them. Now, the data in order to get distances to galaxies usually comes in the form of cosmological redshift. And let me explain what cosmological redshift is all about. This diagram is going to explain cosmological redshift in terms of how light travels across the expanding universe. Okay? And in fact, I'm just going to call it expansion redshift because that's more of a straightforward name. So this light bulb is going to simulate a light source, and it's going to emit a blue wavelength of light. That light is going to travel across space and be observed by the Hubble Space Telescope. But this light is going to travel a long, long time across space, hundreds of millions of years. And during those hundreds of millions of years, space is expanding. Remember, we live in an expanding universe. So as space expands, the light traveling across expanding space also gets stretched, and the light will change from being in blue light, which is a short wavelength, to being in red light, which is a long wavelength. So let me put this in motion. So the light is emitted in blue, and as space expands, it gets longer and longer, and by the time we see it, it is in red. This is the phenomenon that we call expansion redshift. Because red is the long end of the visible light spectrum, we call it redshift because all the wavelengths get longer as they travel across expanding space. So, one can use the measure of expansion redshift as a proxy for distance. Objects that are farther away, the light from them will have been traveling across space for a longer time and therefore will have a greater redshift. Ones that are closer will travel for a shorter amount of time and will have a smaller redshift. So simply, the larger the redshift, the larger the distance the object is away from you. So, how does that apply to our galaxies here in ARP 274? Well, we have some props here to show you. What we see with Hubble, it appears that the center galaxy is in front of the galaxy on the right. But the redshift actually says that the center galaxy has a larger redshift and therefore should be at a larger distance. And that contradicts what we see in the Hubble image. That contradicts what I see with my eyes. And so maybe there really is something peculiar going on in here. It appears that this galaxy is in front of this galaxy, but the data tells me that it's actually behind it. Well, how do we correct this? We remember that expansion redshift isn't the only source of redshift. There's another redshift that can be due to motion, and that's called Doppler. You know about Doppler because you've heard a car go past you and it has a high-pitched sound as it's approaching and then a low-pitched sound as it's receding. Well, that's just a change of wavelength. Let me illustrate. If we have a source of waves, this white dot here in the center will serve as it, and it's stationary, well then as it produces more and more and more and more waves, then all of the waves come straight out from it and form circles around that emitter. And the wavelength you see, the distance between successive waves, in any direction is the same. It doesn't matter if you're looking from this direction or from that direction, you get the same wavelength. Now, however, if that object is in motion as it emits, well then the situation changed. The first wave is emitted around its original position, but the second wavelength it has moved a bit before it emits the second wave, and that is now centered around a new position. The first wave continues to expand around the original center, but the second wave expands around the new center, and so on for the third and fourth and fifth waves that it produces. So you end up with this pattern of waves, which each wave centered around the position of the object when it emitted. So taking a look at that in terms of redshift, well, that means that if you are behind the object and it looks like it's moving away from you, you see a longer wavelength, which means it's redshifted. If instead you are in front of it and it's moving towards you, you see a shorter wavelength, and we call that blue shifting, because blue is at the shorter end of the visible light spectrum. Well, actually, violet is at the short end of the visible light spectrum, but for some reason we call it blue shift instead of violet shift. So, if an object is in motion, you can also get a change in wavelength. Now, how can we apply that to solve the conundrum of ARP 274? Well, you have to recognize that there's both expansion redshift and Doppler redshift happening for these galaxies. It could be that for this central galaxy, the expansion redshift is a certain amount, but it's also moving away from us so that it adds in a Doppler redshift. That gives us a larger total redshift. So the total redshift that we were thinking about in the first place doesn't indicate its true distance. It actually could be closer than the total redshift indicates, because only the expansion redshift is an indicator of distance. The Doppler redshift is just an indicator of motion. Conversely, for the other galaxy, well, then it could actually have a larger expansion redshift than its total redshift if its Doppler redshift is negative, or if it's in fact a blue shift. If it's coming towards us, then its total redshift will be smaller than its expansion redshift, and since the expansion redshift is the one that tells us about distance, it could be at a greater distance than we might otherwise assume. So, for ARP 274, our eyes tell us that the center galaxy is in front of the right galaxy. If you take the total redshift, well, then that says that the center galaxy is behind it. But it could be that we add in Doppler shift and that this guy's coming away from us, this guy's coming towards us. They're actually approaching each other, which is reasonable because gravity is attractive, and that they are actually in the way that we see them with the Hubble Space Telescope with our eyes. How can we tell what is true going on here? Well, you can't separate out expansion redshift from Doppler redshift, okay? Just measuring redshift only gives you the total redshift. You can't differentiate between the two just by measuring redshift. You need another observation. So what we really need is an independent measure of distance for this galaxy and this galaxy. So say, for example, a supernova of type 1a would go off in this galaxy, then we could get an independent measure of distance and use that distance to gauge the expansion redshift, leaving the rest to be the Doppler redshift. And we need the same sort of thing here. So until we have a good independent measure of distance to these galaxies, we can't really figure out what's going on here. So here we have a group of galaxies, a trio of galaxies that is in a peculiar catalog. And when you look at it with Hubble's observation, perhaps it's not so peculiar. But if you look deeper into the data behind it, it actually does become a little bit peculiar. And hopefully we'll find out in the future exactly how to resolve this. That's it for this episode of Hubble's Universe Unfiltered. If you have some ideas for other episodes of Hubble Universe Unfiltered, or you'd like to give us comments on our shows, you can now contact us on Twitter. We're at twitter.com/HubblesUniverse. Please send us your suggestions, your ideas, your comments, and we'll try to get and respond to as many of them as we can. We'll see you next time. Take care. I'm Dr. Frank Summers of the Space Telescope Science Institute. In March of 2009, we held a contest that we called Hubble's Next Discovery, You Decide. And in that contest, we gave you a choice of 6 different astronomical objects that Hubble had never observed before. And we let you decide what would be Hubble's next observation. Well, we received over 140,000 votes, and the winner, garnering almost half of the votes cast, was the interacting galaxies ARP 274. Well, after this Hi, welcome to Hubble's Universe Unfiltered. Astronomical object won the contest. I decided to take a look and see what more information I could find out about it. Because, the image that we used for you to choose was from the Digital Sky Survey, and it's really low resolution and black and white. So I searched the internet for more images, and unfortunately, I couldn't find really great images. The best I could find was actually the original image from the ARP catalog. You see, this is called ARP 274 because in the 1960s, Halden ARP put together a catalog called an Atlas of Peculiar Galaxies.